All right, moving on to mixed numbers. Mixed numbers are rational numbers that are made up of an integer and a fractional part of an integer. A mixed number can always be written as just a fraction, though. So I want us to think about how we can change mixed numbers into just improper fractions. If I think of 4 1/3, then to change this into a fraction, I'm going to think about a model. So I have 4 wholes and then 1/3 of a whole, if I allow myself to think of that as evenly split. So if I want to figure out this as a improper fraction instead of a mixed number, I need to know how many thirds is 4 worth. So I can split each of my wholes also into thirds. And now I can see I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 thirds. Similarly, with negative 3 2/5, I can forget about my negative for a moment and instead just think of 3 wholes, and if I could split this into fifths, and 2/5. So for my 3 wholes, I need to figure out how many fifths each whole will be worth. And each whole is worth 5/5. So I have 15/5 plus 2, 17/5. You might be remembering there is also an algorithm for converting mixed numbers to fractions, but it's easily forgotten. So I wanted to walk you through how you can do it using a figure as well. But essentially, people think of multiplying 3 times 4 and adding it to 1. So 3 times 4 is 12, plus 1 is 13 over 3. But the reason this is working is because we split up the 4 wholes and the 1/3, and then I take my 4 over 1 and I multiply it by the numerator and denominator both by 3, which gives me 4/3 over 3, or sorry, 4 times 3 over 3, and then I can add my numerators together to get 12 thirds plus 1/3 is 13 thirds. And I also forgot to put my negative back in. If we think about negative 3 2/5, in the same way we split up 3 2/5, just pulling our negative out to the front, and then turning 3 over 1 into a fraction of fifths. So 15/5 plus 2/5 is 17/5, and then we consider our negative back again. We can also go the other direction to change 29 into a mixed number. So, or 29 over 5. All right, if each of these is 1 whole, then I can think about how many 29/5 will be. So if I split each of these into fifths. Then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So I can see that this is 5 wholes and 4 fifths, or 5 and 4 fifths. Now, alternatively, we can do some arithmetic to get here, thinking, all right, how many times can I pull out a whole from 29 over 5? So 29 over 5 is the same as 25 over 5, 25 plus 4 over 5. And 25 is 5 times 5. And then I can cancel out the denominator, and I'm left with 5 wholes and 4 fifths. I prefer to think of it using a figure, though. You could also think of it as a repeated subtraction and say, how many times can I subtract 5 fifths from 29 to get the number of wholes? So I would say 29 over 5 minus 5 fifths is 24 over 5 minus 5 fifths would be 19 over 5, and then you would count up how many wholes you were able to get out of 29 over 5, and you should get 5 wholes.